last time, so that means we can spend a bit of time on our folio towards the second half of the double if you would like to. So let's get straight into it. We're going to be combining here our quantile skills with our knowledge of z-scores. So we've got the weight of snapper has a standard deviation of 700 grams, and we know that 20% of the population weigh more than 3,900 grams. Find the mean. Okay, so here's the distribution of snapper. We want to know what's this mean, okay? But we do know that 20% of snapper weigh more than 3,900 grams. Okay, so that's an area of 0.2, right? 20%, 0.2. So the way we're going to do this is we're going to say, what's the z-score that corresponds with this result? So we're going to compare that to a z-distribution. And a z-distribution has a mean of 0 and a standard deviation of 1, right? And so we want to know, what is this z-score that corresponds with 3,900, such that the area here is 0.2. So that's what we're going to do first. What's the z-score? And so we're doing an inverse normal calculation. Our tail in this distribution is pointing to the right. Our area is 0.2. Standard deviation 1, mean 0. Okay, we want to know what's this z-score, what's this number on the z distribution. So let's calculate that. So tail's right, area is 0.2. I've got a z-score of 0.842, it's going to round to. So what does this mean? It means this result that we've obtained here is 0.842 standard deviations above the mean. Okay, now this is the formula for a z-score, right? So if we think about that, we can substitute a number of variables in here, and we want to know what's the mean. So we've got 0.842 is equal to the result that corresponds with that z-score. What's the result that corresponds with it? 3,900. Take the mean and then divide it by the standard deviation. We're told that in the question. We're told the standard deviation is 700 grams. So all this is a linear equation that we're solving for mu. So multiply both sides by 700. And I'm just going to swap mean and this one. Alright, we'll mash that in the calculator. Take 0.842 times 700. And I've got 3,310 grams. Okay, that's because we're talking about weight. Okay, so a quick summary, what do we do? We've got, here's the distribution of snapper, we want to know the mean, and we're saying what's the z-score that corresponds with this? Okay, probability 0.2, we found the z-score, and then we chuck it into the z-score formula, solve for mu. Okay, so that's what we're doing for most of this exercise. Let's get into the second one. We've got the percentage results for a physics test, the percentage result for a chemistry test, and Lucy received an average grade of 83% for physics and 85% for chem. I'm going to do the first part of it here, and then the second part I can use the whole board for. It's going to be good, I think. So let's do the first part here. Which subject did she do better in compared to her peers? So we want to know what's Lucy's z-score for physics and what's her z-score for chemistry. That's all we're assessing here. So in physics, she obtained a result of 83%. And we're going to take away the mean result, which was 70, and divide it by the standard deviation. So what have we got there? 13 on 10.5. Is that 1.23 or something? I'll check in a moment. All right, then we'll check for chemistry. We've got her result was 85%. Take away the mean result, the average is 73. And the standard deviation was 12. Here we've got 12 and 12 with a z-score of 1. Okay, so the question is, which one is higher above the mean? Which result did she do better in compared to her peers? Well, in physics. Even though her result is lower, her performance along the distribution is higher. So she did better in Okay, move on to the next part. Her maths teacher isn't publicly prepared to release the mean and standard deviation of the math results, but he does tell Lucy 6% of the class scored better than her grade of 87%, and 13% of the class failed, received less than 50%. Use this information to find the mean and standard deviation. So what we're going to do here is a process pretty similar to what we did in the first one, except there's going to be two unknowns, and then we're going to combine it together. So let's look at the information that we generated. We have 6% achieved a result greater than 87. Okay, so that's this area here, 0.06. Okay, that's the first piece of information. And then the second one is that 13% failed. So failed is a result less than 50, and that's an area of 0.13. Okay, so that's how the distribution matches up. Now we want to know the mean and standard deviation of this distribution, right? This is the math distribution. And so to start with, we're going to say, what's the z-score that corresponds with this result? Let's call that z1. And what's the z-score that corresponds with this result? And we'll call this one z2. All right. So let's write down the calculations we're doing. Both inverse normal calculations, and we're saying you've got tail, area, standard deviation, mean, and I might do it like this for simplicity, z1, z2, so I don't have to write it out twice. Okay, if we look at z1, the tail is pointing to the right, the area is 0.06, the standard deviation is 1, and the mean is 0. Okay, that's the calculation we're performing for the z-score of 1. We'll mash that one quickly. Normal inverse normal. Right, 0.0610. I've got 1.55. Very good. And then if we look at Z2, we want to know the Z-score that corresponds with 50. All right, our tail is to the left, our area is 13, standard deviation 1 being 0. Okay, that's always the same for a Z distribution. So we'll plug that information in. All right, left 0.13, and I've got minus 1.13 in round 2. All right, so let's talk about what does that mean in the context of the problem. This result is 1.55 standard deviations above the mean, and this result is 1.13 standard deviations below the mean, okay, below because it has a negative z-score. All right, now we can use this information to solve it, all right, because we know that z is equal to x, take mu on sigma. And so if let's do the first one, we've got 1.55 is the z-score. What's the result that it corresponds with? 87. Take the mean divided by the standard deviation. All right, I'll show you what clever skills I'm up to here. We're going to multiply both sides by sigma. Remember, we don't know what that is, that's what we're trying to find. And then we're going to add the mean to both sides. All right, so we're going to have 1.55 sigma plus the mean equals 87. Okay, so that's going to give us one simultaneous equation. Just say what we did there quickly. We've taken this z-score, we've plugged it into the z-score formula. What's the result it corresponds with? 87. And then we've just rearranged that such that we have these two variables here being equal to a number. Let's do it for the other z-score. This is the other z-score. So we're going to repeat it now. Minus 1.13 equals. What's the result that corresponds with minus 1.13? 50. Okay, that's the result. So 50. Take the mean divided by the standard deviation, and we'll process it the same way. Excellent. So here we've got two equations that we're going to solve simultaneously. So I'm going to write them like this under one another. Okay, 1.55 sigma plus mean equals 87. That's the first equation, equation 1. And then we've got equation 2. Okay, now at this stage, if you want, you can go ahead and solve them manually. we're going to use technology. So this is an opportunity for me to demonstrate to you, to recap that process to you. So what we're going to do is we're going to go menu, we go into equation solver, we go simultaneous, and here there are two unknowns. The unknowns are standard deviation and mean. So we press two unknowns. All right, so if you're following along there, simultaneous, two unknowns, and then we input these coefficients. We're going to have 1.55, we're going to have 1 and 87. We have minus 1.13, 1 and 50. And then we just press solve. And I've got standard deviation is 13.8 and the mean is 65.6. And I know which one's standard deviation and mean because standard deviation is the first variable and that's the one that pops up first on my calculator. Alright, let's provide a quick recap of what we did in that question. So, in this question, we're told 6% perform better than 87, 13% perform worse than 50. So they're the distributions, and we go, what's the z-score that corresponds with that result? So we're doing the inverse normal calculation for a z distribution. We've got the area, we've got the tail, we've got that information. We find both z-scores, and then we put both z-scores into the formulas. All right? We process them till we get an equation that we can put into our calculator and solve. Okay, so that's a tricky one that pops up sort of towards the end of the exercise. Most of the exercise is going to start like this kind of stuff here. All right, so let's have a go.